So I'm going to talk a little bit about water in Iowa. And I'm going to start by talking about economics, because I think that I and many of us in this room are really sick of hearing about economics. That's all we hear about from our politicians and all that we hear about on the radio, right? And I think it's always, when we think about economics, the economy of something, what we always think about is money. And money, as we know, creates jobs, and that's a very complex situation. People don't really know how to solve the current problems, but there's a larger sense of economics, economy, and that's nature's economy. The way the natural world, which is so complex that it just makes the financial economics seem trivial, the natural world has, for millions and millions of years, created and supported something called ecosystem goods and services. These are things that the natural world does for us freely, continuously, and these include things like decomposing our wastes, detoxifying pathogens, moderating climate, recycling nutrients and energy, creating soils, controlling pests, pollinating flowers and fruits, and, of course, controlling both the flow and the quality, the purity of water. That and many, many more things are what the natural world does. That's nature's economy, ecosystem goods and services. And those ecosystem goods and services have created a world, a planet, that houses what we think approximately 30 million species. 30 million species, of which we are one. It does this through the interactions and processes of these many species. Through those interactions and processes, it creates a sustainable world or a self-sustaining world. What does that mean? It means that the species living in a sustainable system have a good chance of living and seeing their progeny be able to also create progeny, and the species will then survive. Maybe not the individuals, but the species as a whole survives. This is kind of the ground base of what gives us life, right? The natural world. We all depend on the natural world, although more people now live in urban areas than rural areas. And yet, nowadays, we look at our planet and we know that we have many, many environmental problems. We know that the sanctity of nature's economy may be imperiled. There are several ways to understand that. One is to look at the fact that humans are now so powerful that we have been able to modify the largest sections of our world, namely the oceans. We have changed the pH of the ocean by 0.1 point on the pH scale, and also the atmosphere. The atmosphere until the Industrial Revolution was below, had carbon dioxide below 300 parts per million. In about the mid-1980s, we surpassed what is considered the safe level for carbon dioxide in the atmosphere, which is around 350 parts per million. We're now up at about 390 parts per million. Ecologists look at ecosystems, goods, and services, and it's hard to quantify them and quantify how they are doing, but in general, people say half, maybe 2/3 of ecosystem goods and services are not being used in a sustainable fashion. So that, in essence, how the Tea Party says we're running on our deficit. They want us to keep having a balanced budget, right? Well, we are now, in the natural world, not having a balanced budget. We are using up more ecosystem goods and services than the natural world can replenish. And this is a dangerous situation, because at some point, the functions just don't work anymore. So today, I would like to look at that situation in terms of water. We live on what's called the water planet. About 70% of the surface of the planet is covered by water. And water is crucial to life. The human population is expected to peak in around the next 30, 40 years. And what people now say is that that population peak, if it gets that high, may be controlled not by the availability of food, but by the availability of water. There are now 1 billion people on our planet, 1 billion out of about 7 billion, who don't have access to safe, clean, fresh water. By 2025, in 14 years, we're expected to have 2.5 billion people which will not have access to clean, safe water. And indeed, people are very concerned now not only about the quality of water around the planet, but also about the quantity, either too little water in some places or too much. This, of course, being a picture in Japan, an incredible picture. And that people say that we are living in the water century, that in the 21st century, wars will not be fought over oil as much as over accessibility to water. So now I'd like to narrow down our conversation, talk about that cycling of water, which is determined, regulated by the kind of landform that you're talking about. And so I'd like to talk specifically about the Corn Belt, and in particular about Iowa. The Corn Belt is a piece of land. It's a part of our North American continent where corn grows very well. And corn, as you may know, is a grass. This is a part of the continent that used to be covered by tallgrass prairie. Corn Belt and the tallgrass prairie biome are synonymous. They cover the same part of land. It's a place where grasses grow very well because of the temperatures here and because of the water, because of the precipitation coming just at the right time of the year. And so it was very easy for the settlers to come here and take this diverse, lush, rich tallgrass prairie biome and convert it rapidly, just in the last 180 years, to a land that sometimes here in Iowa seems to be completely covered by a different grass species, but a monoculture of corn, row crop agriculture. That agricultural transformation is really a huge transformation. In fact, it's been called the most rapid and complete ecological transformation in the history of the world. And people also say that now we live here in Iowa in one of the most highly engineered landscapes on the planet, which is quite amazing. The big thing that I'd like you to focus on here is a change from a very complex, diverse ecosystem, about 1,000 species of vascular plants in the tallgrass prairie biome, to an ecosystem which is a monoculture. One species corn, or we might say two species corn and soybeans. And these plants are annuals. So perennials are plants that cover the land year-round, protect the soil year-round, nourish the soil and build soil year-round, whereas monocultures grow just a few months of the year. Very, very different handling of water in those two different kinds of systems and handling of soil, resulting in the fact that prairies were ultimately sustainable and had a healthy hydrology, and cornfields are unsustainable and have an unhealthy hydrology. So that's what we're going to be talking about today, that transformation. And first, let's look a little bit at the tallgrass prairie and how the tallgrass prairie did handle water. Tallgrass prairie covered the United States for about the last 9,000 years. After the glaciers receded, the prairie came back from the southeast and from the southwestern United States. The species joined here in Iowa, eventually covered about 80% of the state, or 28.6 million acres. And the tallgrass prairie was known for its diversity and its abundance of species. Again, 1,000 species of vascular plants, many, many times that many insects and invertebrates in the soils, many birds and ungulates, and in addition to a diversity of species, large numbers of these species. So you've probably heard, for example, of the huge herds of bison, millions of bison in the central United States, flocks of passenger pigeons that would darken the sky for days on end. One of my favorite examples that I use often is the complaining of, or writing in their journals, of the early settlers here in Iowa City who would say that they couldn't sleep at night because of the large number of upland sandpipers flying over Iowa City and keeping them awake. If we see an upland sandpiper today, we're very fortunate. But in the past, those used to be extremely abundant. And the tallgrass prairie was also defined by the processes. It was a land of stress, a land that not only welcomed stress, but depended on stress. And the stresses were the grazing of the large animals and of the insects, drought, and fire. And prairie needs all of those in order to be healthy. The prairie was a wet landscape. About a quarter of Iowa now is defined as hydric soils. These are soils that developed originally in situations where they were saturated for much of the year, long enough to define those soils. The state had a very high groundwater level, diverse and abundant wetlands, springs on hillsides, seeps and swales. Maybe some of you know this area to the little bit in this direction over here, Manville Heights. Have you heard of Manville Heights? Manville Heights in one area has, on the tippy top of a hill, it has a road called Black Spring Circle. There was actually a spring on top of the hill right there next to the Iowa River. That was typical of woodlands across the state. And the water's flow, again, the quality of water was shaped and regulated by the prairie. And in particular, and the quantity, in particular, the prairie did two things. For one thing, it recycled a lot of the water immediately back into the atmosphere. And if the water did get into the soil, it clung to the soil like a giant sponge and released that water reluctantly and very slowly. So to understand those two processes, we need to look first at the above growth, the abundant growth above the soil of the prairies, and then look at the deep, dense roots of the prairies. So if you consider the fate of the falling rain on a prairie, remember you have lots of species. These species have different heights. They have different leaf shapes, different densities, and the like in the prairie. And much of the water that falls onto that prairie with all these different shapes and forms would be caught in the leaves and evaporate immediately. So it would come down from the air and be recycled back into the air immediately. If it did get down to the soil, then it would be absorbed by the plant roots, pulled up through those plant roots, and released again into the sky through a process called transpiration. You might remember that from beginning biology class. And in those two ways, the water was consistently released back into the atmosphere. If water did get down into the soil, if it got down and kind of wiggled through all of that thick thatch that's typical of a tall grass prairie, it would get into the soil. These soils were deep and rich, average of 16 inches of topsoil in Iowa. The soils are 5,000 to 9,000 years in creation. Iowa has 1/4, 25% of the world's grade A topsoils, incredible, deep, rich topsoil, very rich in organic matter because the root masses were so dense and deep, 10 to 20 feet deep. Typically, in very dry parts of the state, like the Luss Hills, the roots could go down much deeper than that. 2/3 or more of the plant's biomass was actually down below the ground's surface, and the organic matter in those soils helped to hold the water. And the prairie soils, as I said, were like giant sponges because of something called macroaggregates. These macroaggregates were basically little balls. I like to call them slime balls. They were mixtures of mineral particles and bacterial, exudate, and then organic matter that all kind of crunched together and was held together by this slime exuded by the bacteria into little balls in the soil. So that if you picture this room, for example, being filled up with ping pong balls, you can imagine there would be lots of space between the balls, and that's exactly the way the prairies were with these relatively large macroaggregates. Half of the soil's volume was actually air. So if you can think about what a sponge looks like, when you look at a sponge, you're looking at solid matter, but you're also looking at air, and that's the way it was with the soils. Here is a photomicrograph of a prairie soil. This is from Doolittle Prairie in central Iowa, and you can see the large air spaces in that prairie soil that would soak up and hold water. Once the water got into the soils, it would eventually be released into slow-moving seeps and shallow swales, into stream bottoms that were stable and not down-cut, kind of like this fen in Iowa here now, so that the typical river that we picture now with kind of curving banks coming down and then a big slot through which water flows didn't exist, we don't think, in pre-settlement times. Instead, we had these kind of curved stream bottoms where the flows were steady and slow, and water levels, the water seeping down into those swales, would rise and fall very slowly so that floods and droughts were moderated. You'd had floods in pre-settlement times, of course, but they wouldn't be as severe as those that we had today. And essentially, in the tallgrass prairie, you had no erosion, no pollution, and a flood-resistant landscape, very different from what we have today. The hydrology of the prairie was then called a consumption or infiltration hydrology, a hydrology where the water soaked into the prairie, was held by the prairie, and was consumed by the plants. The agricultural transformation that again occurred rapidly, very rapidly, produced immediate and profound changes in this hydrology. Come on in. A little baby out there. Starting in the 1830s, right around Iowa City here, this is where the official settlement of Iowa began. We had the native plants and the animals stripped off of the land and an entirely new ecological system brought in of non-native agricultural crops and livestock. So essentially it was like taking the skin of the planets, the skin of Iowa, scraping off that diverse set of plants and animals that lived here, and replacing it with a conglomerate of species that came from different continents, from mixed continents and from mixed sites. And that was done first by removing the prairie physically, by plowing the prairie, but it was also done by changing the processes that governed the prairie, by removing fire, that was very important, and also by overgrazing. The bison, of course, did graze the prairie and browse the prairie, but they were always moving on the prairie. So they didn't have a really intense impact on any one site for the most part, whereas cattle tend not to. They tend to graze in a little bit different pattern and to stay in one place. So this intense grazing and the elimination of fire and other stresses really did the prairie in very rapidly. Essentially, we don't have tall grass prairie remaining in Iowa. And the result was that the flowing of water changed from an infiltration or a consumption hydrology to a hydrology where you had surface flow, the water flowing over the surface of the land rather than going right back into the air or down into the soil. Very different process. And you can see that in this picture right here, which was made, this is a sketch that was made in the 1870s. You can see and imagine the water coming down on the cattle yard at the top of the picture there, and the cattle have trampled that soil and compacted that soil so that it can't soak up the water anymore, added manure to the soil so that instead of the water going down into the soil, it sweeps down into that cornfield, carrying the manure, carrying the feces with it, down into the bottom, through the cornfield that has relatively few plants, down into the valley bottom, where it flows rapidly off into larger and larger streams and eventually into the Gulf of Mexico. And you can see indeed that instead of a nice shallow swale at the bottom of the picture, you have a deeply incised stream. So the soils were bare and trampled. And if you look at photomicrographs of row crop soils compacted to prairie soils, you can see that there is much less white space in the row crop soils. That's partly because, as I said, they've been compacted. It's kind of like somebody standing on a sponge and squishing out those air pockets, and also because the soil particles, those macro aggregates, have been broken down into smaller and smaller clumps. A lot of the organic matter is gone from soils now. So there's little airspace left for water compared to what we used to have in the past. So Iowa's hydrology has been rapidly redefined into a runoff hydrology, and this was the onset of the environmental problems that we have today. Soil erosion and water pollution, we had them within decades of white settlement of the state, and they remain our largest environmental problems here in Iowa today. After the prairie was plowed, we had people drying the land. Remember that a quarter of the state was very wet, was essentially wetland, and water was viewed as a hindrance. And so people starting in the 1870s started to put these tiles, as you see in the upper picture here, actually cut little slots into the soil and put down clay pipes in the soil that had holes in them. And the water would flow through the soil into the holes in those pipes, and then those pipes would be fed into a ditch or into a river, and the water would run rapidly away. About 25 to 35% of our cropland today is drained through drainage wells, and we have ongoing improvement and increasing in the amount of land that's tiled through something called the Iowa Plan. I think that's a nice euphemism there. This is now being enacted by the Iowa Department of Agriculture and Land Stewardship. It's a very contentious plan, but it seems to be going ahead, at least on a trial basis. People also straightened streams. About 3,000 miles of streams were lost. Why would they do this? Well, because if you have a straight stream, the water rushes off the land faster, right, than if you have a meandering stream. So people would take a nice meandering stream and essentially cut a ditch through the middle of it to increase the speed that the water flowed away. People also cut new drainages and deepened streams throughout Iowa. And this big trencher right here, it looks like something that we would be using today. That picture was actually taken 100 years ago, around 1910. So people had big machines 100 years ago modifying the land in a big way. And there were lots of gains of drying the land. The soils in the landscape were drier. The groundwater was deeper. So more land was open to farming. The land was easier to plow. And the yields, crop yields, went up. But the landscape is now engineered to shed water rather than to hold water. Less water is stored in the soil and on the land. The water runs faster. Again, these are all very major changes in the way the land holds water. We have both surface flows and underground flows. Water goes very fast into creeks. It has more erosive power. Streams are flashier. That means that the water comes up and down very rapidly. And stream banks are incised rather than shallow. How many of you were downtown last night, about 6 o'clock, when we had that incredible storm? Wasn't it amazing? And within probably 5 minutes, the streets in downtown were 6 inches deep. I mean, I have never seen anything like it. But that's the kind of thing that you have with a landscape not designed to absorb water. It's said that a healthy tallgrass prairie can absorb about 8 inches of rainfall in a day. 8 inches of rainfall in one day absorbed by the prairie. Now we're down to about 1¼ inches in a natural, in an unconverted landscape, not on, if you look at a paved road or something, you don't absorb virtually any water, and that's what we had in downtown city last night. So, very different hydrology to think about. The rivers also are carrying more water now. Why is that? Because we don't have the same amount of water returning directly to the air, and the rivers are running fuller so that we have increased flood potential. And if you look at the graphs of annual runoff of rivers across the state, you will see from about 1950 to the present that runoff has doubled. So since 1950, we've had increases in the average annual discharge, average daily stream flow, and the number of high flow days, and also the minimum flow in rivers has increased. So it's gone up in all ways. So by 1900, we had plowed the prairie, we had tiled much of the land, but we still had many diverse small farms. We had horses that ate hays and grain. We had crop rotation. Farmers had to rotate crops in order to control pests. You couldn't grow the same crop on the same field year after year, or you would have insects destroying the crop. You had to have manure for fertilizer, and so you couldn't, you had to have livestock on the land. And you had to have, as a result of all of that, you had perennial cover, the farms mimicked the prairie. So the landscape around 1900 looked very different, but it was a lot more like the prairie in function than the landscape that we have today. Then what happened about between 1900 and 1950 and going on to the present is that perennial cover was removed. So first the prairie was removed, replaced by imported perennial cover. Then the perennial cover was removed, and that was done by substituting, for one thing, horses for tractors, so that you didn't have the need for hay and for grain anymore with tractors. After World War II, we started to get chemical fertilizers and synthetic pesticides, so we no longer had the need for manure or for crop rotation. And also, starting in the 1930s with the Great Depression and Teddy Roosevelt's programs, we had government subsidies and policies that started to shape crop selection and which are really now pushing production of row crops at the cost of other kinds of agriculture. And all of these changes advanced annual row crops at the cost of decreasing perennial cover, so that they all pushed this hydrology farther into a runoff hydrology. And indeed, if you look at a graph between 1860 and the present of row crops versus sod crops are perennial crops that would be covering the land year-round, and they were actually pretty constant. Once the prairie was plowed, farmers put in sod crops until about 1940 or so. Then they've decreased to very little of the landscape, whereas row crops have gone up. We have corn and soybeans now covering about 2/3, about 65% of Iowa is in row crops. And all the row crops, again, have less water holding ability, more of a runoff hydrology. And then the last change between 1950 and the present is that all of these trends that we've been talking about have been pushed to the extreme. We've had an intensification of farming. We've gone from small to large in multiple ways. Farms have gone from small to large. Fields are larger now. Machines are huge compared to what they used to be. We've gone more and more from diversity to simplicity, and now we talk about industrial agriculture and factory farms. Those terms, for somebody who kind of understands the idea of ecosystem goods and services, the phrase a factory farm or industrial agriculture is a very painful phrase. You know, it just doesn't work because you cannot treat a living system as if it were a factory, and that's what we're trying to do here in Iowa now. Tremendous simplification of agriculture and the landscape. Agriculture's domination by 2 annual row crops, so that if you look at a map of the pre-settlement prairie, which used to cover 4/5 of the Iowa, and then a map of corn and soybeans, which now covers about 2/3 of Iowa, you can see that they're essentially in the same place because the prairies produce the soils that allow corn and soybeans to be grown. And today, if we look at the distribution of prairies in Iowa, we have very few prairies remaining. The largest prairies remaining are in the Luss Hills in western Iowa. So the other thing that I should mention, is talking mostly about the quantity. Thank you, Holmes. That's talking about the quantity of water and the way water runs off the land. But we also can look at the quality of water and how that's changed. Before World War II, we did have water pollutants, mostly sediment and manure, right? Once you plow the prairie, the soil is going to run into the rivers and manure is going to run in. But after World War II, we had a huge increase in the different kinds of pollutants that have run into the water, so that we have chemical fertilizers, synthetic pesticides, feed additives, antibiotics, all sorts of synthetic chemicals that didn't exist earlier in the 1900s. We also have concentrated animal feed waste from CAFOs, confined animal feeding operations, urban waste, lawn chemicals, and the like. So tremendous quantity of pollutants, which means that we still have a lot of sediment washing into the soil now, especially during floods. In 2008, we had some sites here in Johnson and Linn County where we had 50 tons of topsoil per acre eroding into the rivers. The maximal allowable erosion is supposed to be 5 tons per acre per year. We had, 2008, 50 tons per acre per day. Incredible quantities. And a flush of complex pollutants. Iowa now has among the highest fertilizer and pesticide use in the nation. 2005, I should really get more recent figures, but in 2005 already we were putting 1.7 billion pounds of nitrogen on corn in Iowa, 25 million pounds of herbicide on corn, and that doesn't include what we put on soybeans. And those pesticides and the sediments from Iowa don't stay here in Iowa. They run, again, down the river into the Mississippi, into the Missouri, and from there down into the Gulf of Mexico. And you can see New Orleans here near the bottom, and huge sediment plumes that are coming out from the water, discharging into the Gulf of Mexico. And along with those sediment, we have the fertilizers that enrich the water and essentially lead to the creation of a dead zone in the Gulf of Mexico, which is growing larger and deeper. So what have we lost in Iowa? Well, we've lost prairies, but a lot of people say, well, so what? We can live without prairies. And we've gained a whole lot. What have we gained? We've gained a lot of corn, we've gained a lot of soybeans, and biofuels. We've gained biofuels in Iowa. But this has come at a cost. The cost is that the soils no longer function as they once did. Iowa's soils have been redefined. This is a picture on the far side, is a picture of a low quality, but it's a prairie remnant. Not a very good one, but it is prairie. And on the other side, it's a grazed pasture. You can see the erosion taking place there. We've lost about half of that 16 inches of topsoil in Iowa. We've lost those marvelous macro aggregates that made the soils like a sponge. The pore space and water retention quality of soils have decreased. We've lost about half of the organic matter in soils. Fertility's declined. The soils have collapsed, been compacted. Iowa's streams have been redefined. What used to be slow-moving swales, shallow swales, are now fast-flowing, eroded, polluted, and flashy. And you can see that kind of sharp cut in the earth rather than a shallow swale. Or we simply call them ditches. If you don't believe this, simply look at a map of Iowa and you'll see the Niobrara Ditch or the Little Sioux Ditch, especially in western Iowa. There have been major changes in wetlands, in the types of wetlands and the diversity of wetlands. Remember that the groundwater table used to be very high, so that wetlands were fed by the water coming through the soil into the wetlands, right? Now we have water coming over the surface of the land into the wetlands, and the water brings with it pollutants into these wetlands, so that they're very, very different in character than they used to be. They now concentrate pollutants, and the water levels are often erratic, which has a big impact on the plants there. And the quantity and quality of water has been redefined. We now have rapid flows, surface runoff, tremendous erosion, complex of pollutants. And I think one of the major things is that water and soil, Iowa's biggest blessings, see, the biggest gifts we've been given, people around the world would give their IT for the soils and the water that we have here in Iowa, are now viewed as problems rather than as valuable resources. And one expression of that is that we now look at flooding in the Midwest and in Iowa as the new normal. This is only true as of, 2008, I think it was 2009, after we had the big floods in 2008, and then in 2009 we had more flood frights, flood scares, and people started saying, well, this is the new normal, we should expect flooding here in Iowa. But it didn't used to be that way. The land's flood resistance has definitely declined. We used to have floods in the past, but the floods are faster and flashier. That means they come up and they go down, kind of like that big rain last night. I mean, it was just amazing. It was just a matter of minutes until we had 6 inches of water on the streets in Iowa City, and that's a flashy flood. I came back this morning, the streets were completely dry. So the floods are coming up and going down faster. The size and the peaks are higher. They may be more frequent, although we don't know that statistically. But the more water, greater flood potential is due definitely to the landscape alteration that we've imposed on the land. But there's one more complicating factor, which is climate change. Iowa's climate is changing. Iowa's getting wetter and warmer. Precipitation's increasing, steadily increased, with the largest increases, the strongest increases are in eastern Iowa. Cedar Rapids has gone from something like 27 inches average per year in the late 1800s to around 36 inches per year now, which is a huge increase. We have more rainstorms that are over 1.25 inches since the 1950s. And remember what I said about prairies, that they could absorb 8 inches of water, and now we can absorb 1.25 inches. So that figure is important, because if we have more rainfalls greater than 1.25 inches, it means that anything above that amount will go immediately into streams. Below 1.25 inches, the soil is going to be able to soak it up and handle it. Above that, it goes right into the streams and starts causing flooding. We have greater atmospheric humidity related to higher temperatures. Warmer air can hold more water. 13% rise in humidity since 1975. Greater soil moisture. Rises in precipitation, stream flow are expected to continue. And what the climate change modelers say is that we're going to have a 50% increase in upper Mississippi River stream flow in the next 50 years. Huge increase. Imagine the entire drainage of the Mississippi River carrying 50% more water than it does now, yet that's what the models predict. And more water, especially more runoff and stream flow, means that we'll have rising flood potential. And in particular, the trait with the highest statistical significance is that we have increasing frequency and intensity of heavy precipitation events. Heavy precipitation events have increased by about 1/3 in the Midwest, 2/3 in the northeastern United States, and elsewhere throughout the country as well. So this is a little aside right here. This is a little plug for my home institute. IHR Hydroscience and Engineering has a new center called the Iowa Flood Center, and if any of these figures are appealing to you, and if you like to play around with computer maps and GIS systems and the like, we have something called, we've just released in the last few weeks, the Iowa Flood Center's Iowa Flood Information System, or IFIS. And this is a watershed-based interactive real-time web platform for multiple hydrologic traits, such as flood inundation maps, cumulative precipitation, flood predictions, flood probability calculator. You can go to your own house, for example, and zoom in on it on the map, and then you can calculate the probability of your house being flooded in the next 5 years, the next 50 years, the next 500 years. It's pretty cool. So if you would like to look at this and play around with it, you can just Google the Iowa Flood Information System and it should come up. So going back to the talk once again, the Corn Belt. Do we need to consider that the Corn Belt is an ecological sacrifice zone? Have we gone too far? Nobody is arguing, I don't think, that we shouldn't have used these incredible topsoils here in the Midwest. I mean, obviously, people coming to Iowa were going to plow the prairie. But have we gone too far by having 2/3 of the state covered by 2 row crops? And I would argue, yes, we have. And that we need to reverse the resulting problems with soil erosion and with changes in water quality and water quantity, and that we have 2 options for doing that. First of all, we can ignore nature and replace ecosystem services with technology. And that's what a lot of people argue, right? I mean, even with climate change now, you can read on the web any day, you can read plans for seeding the atmosphere so that it'll reflect more of the sun's radiation so that we don't have as much global heating, for example. So we have technological cures to environmental problems, or what I would like to argue for is that we may need technological systems, but we also need to be able to work with nature and to return ecosystem services to their health and their integrity. And that this makes a lot more sense financially, economically, as well as aesthetically and all sorts of other ways. And if we work with nature, we can reduce our soil and water problems simultaneously. So again, we're always going to have technological services, technological solutions. If you think about a waste treatment plant, such as the one shown right here, that's basically the technology that we've used to replace the prairie, right? The prairie doesn't cleanse our water anymore, so we have our water treatment plant producing pure water. We're not about to give that up. But if we reverse that arrow and take a portion of the land, a portion of these row crops, and put them back into healthy perennial cover, and then a portion of that healthy perennial cover, put it back into healthy, diverse ecosystems, we are going to be functioning a lot better here in Iowa. We can get the water back into the soil by doing this. We can slow water's flow. We can increase the soil's organic matter and porosity, increase perennial cover. And to do that, we need to change agriculture. I mean, nobody's saying that we don't need to change the runoff in Iowa City as well, so we don't have those incredible floods. But most of Iowa is covered by row crops, and that's what we need to address. And the thing is that we know what to do. We have agricultural systems. It's not like we have to develop more techniques to figure out how to get water into the land. We know about no-till farming, we know about grass-based farming, we know about land set-aside programs, and alternating row crops with perennial grasses, things like buffer strips, things like breaking tiles at the edge of buffer strips, remeandering streams, on and on and on. We have the techniques, and we don't do them. We know about getting water back into the soil in cities. There are all sorts of techniques that are being implemented in Iowa City and across the state right now. Things like landscaping with deep-rooted natives, green roofs, bioswales, rain gardens, many other techniques for getting the water into the soil in highly developed areas. But restoring the native plants and animals and communities and their functions is what I call the gold standard of restoring the land and restoring these functions of the ecosystem so that the ecosystems can better serve us. This is the field that I work in personally, is a field called ecological restoration. And it can be done in two ways. One is by rebuilding native communities from scratch. We know how to do this now. If you want to construct a prairie on an old cornfield, you can do it. You can go down to Prairie Lights, buy a book, and within 3 years you'll have something. If you do it, if you follow the directions, it's kind of a cookbook. You can have something that looks like a prairie within just a few years. Or you can return health to native remnants where some native species still survive. And there are an amazing number of places in Iowa where this is true and where this is going on. And what I've proposed in my writing and in my talks is that a goal for Iowa would be to have half of the state in perennial cover. Now we have about a third of the state in perennial cover. If we aimed for getting half of the state back in perennial cover, it might not be enough, but it would be a good start and it would be a good goal to aim for. And then about 10% of that half of Iowa, 10% of these of Iowa's perennial cover would be in managed native communities. So they would be in managed native savannas or prairies. And one of the encouraging things, I think, that is that the land is so eager to respond. It's amazing to me. This is a piece of land that is owned by by a professor and her husband here, Erin Irish. John knows her. This piece of land used to be an old cow pasture. I think that Erin and her husband bought it about 8 or 9 years ago. It's near the Cedar River, 40 acres. The land stunk. It looked like a bunch of weeds. You couldn't step any place without stepping in cow pies. They thought that they were just getting a piece of country land to retire on. And then they had to figure out what to do with the land to manage it. And somebody said, well, let it go for a little bit and start burning it. They did it. They became engrossed in prairie restoration. And today, 9 years later, they have a piece of land that looks like that. They had prairie species that had survived basically as root systems with maybe 1 or 2 leaves coming up each year. These prairie plants had survived for decades. Once given the chance, the prairie plants returned. And this is not an unusual story if you find the right lands here in Iowa City. So that in Iowa, our land is eager to give us the ecosystem goods and services once again if we allow it to do so. So we know what to do. Why isn't this happening? I think there are all sorts of reasons, and they're the same reasons that are affecting the problems, I think, with our financial economy. Lack of education, reluctance to face the facts, lack of political will, greed, habit, reluctance to change, etc. We have all sorts of excuses for continuing down the same paths that we're going down right now, even though we know that those paths are not sustainable, may lead to larger problems in the future, larger problems for our children. Still, we continue in the same patterns. And the quote that I like to think about is something that I read in one of Thomas Friedman's books. If we think about economic realities, both financial realities and nature's economy, if we want things to stay as they are, things will have to change. If we want to live in a world that sustains diverse life, in a world that most of us have experienced as a beautiful and self-sustaining world that nurtures our spirits as well as our bodies, then other things are going to have to change to support that world and to nurture that world once again, rather than to continue to live with deficits as we are with our natural world right now.